All right, this is Note-Taking Guide 9.3. We're going to talk about the area of a triangle and the law of sines. Now, just to make clear, when we're talking about the law of sines today, up till this point when you've used your sine function, it's only been able to be used on a right triangle. Today, this law works for every kind of a triangle, not just right triangles, okay? So we're going to talk about these two things today, but before we get started, I want to just talk about some conventions of triangles. So things that happen always no matter what, okay? So on this paper right here, I want to talk about how we label our angles. Does anybody know what kind of letters we use for our angles?
A, B, and C.
Yeah, well, it's usually A, B, and C, X, Y, and Z, E, G, and F. They're usually in order, right, alphabetically, but they're always going to be uppercase letters. That's important to know so that when we're using our formulas today, we know whether or not it's talking about an angle or it's talking about a side. So for instance, if I label this triangle A, B, C, my angles have to be labeled with uppercase letters. Okay, so guess what that means for my sides?
Lowercase.
They're lowercase. Now, I don't know if you guys have ever noticed this before, but our sides always come from our angles. Okay, so looking at angle A, the side that does not make up angle A is called side A. So looking from angle B, the side that doesn't make up angle B is called side B. And then the one that doesn't make up angle C is called side C. This is the way that triangles have been labeled like your whole math career. You probably just haven't noticed it. Okay? So if I label this one capital X, capital Y, capital Z, could you guys label the sides for me? How many of you noticed that before, that that's the way your triangles were labeled? Nobody? A couple of you? So what's this side over here going to be?
X,
X. This one?
Z,
And this one?
Y.
Y. Okay, now that we know that, it's going to make it really easy for us to be able to follow our formulas, okay? Now, just before we get going on our formulas, I want to remind you how we find the area of a triangle. Does anybody remember how to do that? Go ahead. Do you remember the area formula? Yeah, 1/2 the base times the height. Does anybody remember what the base and the height have to do? They form something together.
Don't they have to form an angle?
What kind of an angle?
Right angle.
Yeah, they have to form a right angle together. So do we have our height going on here yet? Nope. Our height actually goes from that tallest angle down to the base, forming a right angle with the side. Now, because that is forming a right angle right there, I actually can do some right triangle trigonometry. Okay? So this formula works out really good for me, but do you see how I'm going to have to solve for the height because I don't know what it is? I form a right triangle, and I could set up a function. I could go opposite over hypotenuse. Anybody know what function that would be?
A squared plus B squared equals C squared.
Okay, how about opposite over hypotenuse? Which trig function is that?
Sine.
The sine. So does it make sense that instead of using the height, I could use a sine function in my formula? Okay, so that's where this is derived from. We know that the area is 1/2 the base times the height. That's what you guys just told me. And we know that it forms to a right triangle. This over here is these new formulas that will work for us when we can't find the height of that new triangle that we're looking for. Okay, I want you to take note about these. We have 3 formulas that do exactly the same thing. The reason we have 3 different formulas is because it depends on what parts of the triangle we have, which formula we use. But I want you to notice how easy this is to memorize. If I have angle A, which sides am I going to use? B and C. Did you see how I didn't use A? If I have angle B, which 2 sides am I going to use? A and C. Okay, and if I have angle C, which 2 sides am I going to use? A and B. So really, this is still the area formula, 1/2 the base times the height, but we're using a sine function to find the height. Okay, you following me on where it's coming from? So really now we're just going to plug into the formula and use it. It says find the area of a triangle with sides A of 11, B of 5, and angle C measures 20. So without even flipping back over, can you guys tell me which formula it's going to be? 1/2 of what? AB sine of C, right? That was what the formula was on the other side. Those are easy to memorize, aren't they? So we can memorize those formulas just by looking at the angle that we're using and then remembering we're using the other two sides. So 1/2 of A times B times the sine of C. Okay, the most commonly missed problem on the last test was that you guys didn't turn your calculators into degrees when you needed to be in degrees and radians when you needed to be in radians. What is your calculator to be in right now? Degrees. So make sure your calculator's in degrees and then just punch this into your calculator. So you can do 1/2 times 11 times 5.
9.400.
Do you guys agree with her? 9.41 if we round? Right? If I go rounded.
It says round your answer to the nearest thousand.
Oh, so we could have gone one more.
So 0.5?
0.6 probably if we're going to the nearest thousand. I'll just change that to 0.6. That's okay. Okay, 9.406. Is there anybody that didn't get that number and needs help with their calculator?
I got the exact same thing you did.
Okay, questions on how we plug that in? All right, this time we're going to be missing a part and we have the area, but we're still going to just plug it into one of our formulas and solve it. So this time it says the area of the triangle is 26.5 centimeters squared and two of the sides are 8 and 9. What's the angle, it says? Now, does it really matter which one of the triangles formulas I use this time to find the area?
No.
Don't they all use two sides and the included angle? Yeah, so it doesn't matter which one I do. But I know that the area is going to be equal to 1/2 the first side times the second side times the sine of the angle. What letter do you want to call the angle?
Theta.
Okay, I'm all right with C, whatever you want to do. You could totally have called it theta if you wanted to, but really we're just solving for the angle. So, can you figure out what this number is right here? 1/2 times 8 times 9?
It's 36.
Yeah, it is 36. So I have 36 times the sine of angle C still. How do I get C isolated? What am I going to move first? Yeah, divide by 36 because it times by the sine. So I have the sine of C equals 0.736.
Yeah.
Okay, one last step there. Who remembers how I'm going to get rid of the sine on the C?
Move it over to make it a percent.
You do
Right.
the sign, the negative.
Yeah, I do the inverse sine function, right? So I'm going to do the inverse sine function on my calculator, the sine -1 of 0.736, and that will give me my angle. So tell me what my angle is.
7.31, 39.7.
47.3.
47.39.
Yeah.
If you rounded or didn't round on this number, like I left mine on my calculator, mine ended up to be 47.4, almost exactly. So if you're a little bit off, that's okay. And this is in degrees, right? Because that's an angle measure. All right, questions on how we did that? All right, here's just a little joke to make you laugh. What did the buffalo say to his son when he left for college? Bye, son. Ah, funny, right? Okay, not. This is my favorite rule of triangles because it works so easily. It's called the law of sines. So say you have a triangle that's not right, and you're missing a part of it, you can use this law of sines, which is really setting up a proportion in order to solve. Now you can do, notice here how it says the sine of A over A, sine of B over B, and sine of C over C. You're not going to use 3 parts of this to solve. You're going to use 2 parts. You're going to set up a proportion and you're going to solve. It doesn't matter which 2 parts that you use. You just pick 2 of them with the information that you have. You set up the proportion, and then does anybody remember what you're going to do when you have a proportion? You're going to cross multiply to solve this. Okay? So it's going to make it really easy. So here's the plan. I have to find on my triangle 3 of the 4 things. Because if I don't have 3 of the 4 of them, I have too many variables, right? I need to get it to only have 1 variable. So look at this triangle with me right here and see if I know 2 parts, like my big A and my little a, or my big B and my little b, or my big C and my little c. Do I know any of the 2 parts there that I can use for my proportion?
A, C, and like then two.
So A is here and little a is there. So I'm missing little a, I'm missing little c, and I'm missing big B. But guess what I know about 3 angles in a triangle?
And they add 180.
They do. So if they add to 180, do I know what angle B is? How much?
840.
It's 40. So now do you guys see that I have angle B and I have little b? Right? So I'm going to set up a proportion using those 2 parts. So it's going to be the sine of the angle over the side, which is 24. So the sine of the angle over the side, and then I'm going to equal it to the sine of the angle and the side that I'm looking for. And guess what it says I'm looking for right now? A. So I'm going to do the sine of A. Do I know what angle A is?
Yeah.
Yeah, it's 118. Do I know what side A measures? No, so little a goes on the bottom right here. Does everybody understand how I set up that proportion?
Yeah.
Okay, what do I get to do now? Cross multiply. Sine of 40 on your calculator, you guys. It is a calculator problem. Sine 40, enter. 0.642 or 6.643 if we round. Is that okay?
Yeah.
And that would be times by A. And then I'm going to equal it to the other direction. You can seriously just punch this in your calculator. 24 sine of 118. So 24, you can put a times sign if you want to, but you don't have to. 24 sine of 118, just like that. Hit enter and you get 21.19 or 21.2. How do you get A by itself? Divide by 0.643. And what's your side measure? I heard somebody whisper that. Is that what you said?
It's actually 32.7.
32.9.
So here's the thing. It depends on how you rounded or didn't round. Do you guys see how I just used my calculator? I just said take my answer and divide it by something. So if you round and you're going to end up a little bit off. It's okay. All right. 32.96, 32.7, close enough. Okay. My dad used to say close enough for government work. My dad was a missile mechanic. How does that make you feel? Probably not like it's close enough, right? All right. Next problem here. I'm going to again use my B's because I have both of them and they were beautiful to use, right? So I'm going to go the sine of 40 over 24. You guys agree those are my B values?
Yes.
And what am I looking for this time?
C.
C's. So it's going to be the sine of my C value. Do I have my C value?
No.
22. And then over my little c because it's my side. I'm going to cross multiply and I'm going to solve. What's the sine of 40 on your calculator? Yeah, we already found that, didn't we? 0.643, and that will be times by c. Then on your calculator, 24 sine of 22.
It's 8.9.
8.99.
Yeah.
How do I solve for C?
Was 13.98.
13.98. Pretty close to 14, right, for your answer. Okay, that's the law of sines. How do you feel about it? My favorite rule of all of trigonometry, because it works so easily on so many different kinds of triangles. So keep that rule in mind always.